Okay, so we're going to be doing the balancing chemical equations with Cheerios. So if you have not watched the math version of balancing chemical equations, you need to go do that either before or after you watch this video. So this is just a different way of balancing chemical equations, but essentially you're doing the exact same thing. So the first thing that we're going to do is we're going to identify the different colors that we're going to put in association with the elements in the equation. So the very first one, I'm going to associate N as green, and I'm going to associate H as blue. Then I'm going to go through and I'm going to identify all of my subscripts, whether they're written or not written. So my subscript for N is already written. My subscript for H is already written. Over here, my subscript for N is not written. And so I'm going to identify it as a 1. Because remember, coefficients and subscripts that are not written are basically invisible ones. Then you have H, and it's written as a 3. So then I'm going to go through, and I'm going to put down the correct amount of colored Cheerios. So I've identified N as being green, and we see there are 2 of them, so I'm going to put 2 green Cheerios. Then my H's are blue, and I have 2 H's, so I'm going to put my 2 blue Cheerios. Then on my product side, I have 1 N, which was identified as green, and 3 H's, which we've identified as blue. Now, whenever you're doing the Cheerio activity, remember that these are, or any really, whenever you're balancing chemical equations, remember these are compounds. So, like if you put a 2 in front of, like a 2 coefficient here, that means you're going to be adding a whole, you're going to have 2 whole compounds. So you have to have all of those Cheerios double. So let's go through and see how many we need to balance. So we've got 2 greens over here and only 1 green over here. Well, the easiest way to figure it out will be to figure out how many we need to add where they are going to be the exact same number. So I've got 2 greens over here and 1 green over here. The lowest like common number they could be would be a 2. So I'm going to have to add a whole nother compound and put a 2 right here. So I'm going to have to add another green, and then I'm going to have to add 3 more blues. So I have 2 of these whole compounds, which means I have 2 N's and then 6 H's. So I have 2 greens and then 6 blues. So now I have 2 greens on my reactant side and 2 greens on my product side, but I have 2 blues on my reactant side and 6 greens on my product side. So in order for me to get the lowest common number between these blues, I need to have 3 compounds of the blue. So I need to multiply this H by 3. So I'm going to put a 3 here, and then I'm going to have, I've already got 1 of those compounds, and so now I have another of those compounds, and now I have a third of those compounds because I have a 3 coefficient. So I have 2 greens in my reactant and 2 greens on my product. Then I have 6 on my reactant and 6 on my product. So I am done balancing this equation. So if you were to do it as the math part, you would have your reactants and your products. You would have N and H. You would start out with 2 N's on your reactant and 1 N on your product. And you would start out with 2 H's on your reactant and 3 H's on your product. In order to make your nitrogens the same, you're going to have to add the 2 coefficient over here, which now makes that a 2, and it changes the H's to 6. Then you're going to have your nitrogens in balance, but in order to make your H's the same, you're going to have to add the 3 coefficient over here, which makes that a 6. So that would be the math way of doing this equation. All right, on to the next one. So I'm going to identify K as orange. I'm going to say Cl is green, O is blue, and then on this side I've got the orange, the green, and the blue. So then I'm going to go through and identify my subscripts. So I've got K with no numbers, that means it's a 1. Cl with no number, which means it's a 1. O is 3. K, no number, is a 1. Cl, no number, is a 1. O is 2. So then I'm going to go through and put my Cheerios. So I have 1 orange, I have 1 green, and I have 3 blues. Over here, I have 1 orange, 1 green, and 2 blues. Okay, well, my oranges are balanced and my greens are balanced. My blues are not balanced. The lowest number that they can both be would be 6. So in order for me to make this 6, I'm going to have 2 more of the 3 compounds, or the compound of KCl3O, or O3. So I'm going to have another orange, another green, because I'm trying to get this as a 6. So I had to multiply all of these by 2. So now I have 2 Ks, which is orange, 2 greens, which are Cls, and now I'm going to have 6 blues, which are my oxygens. So now, over here, in order to have 6 blues, I'm going to have to multiply this by 3 to get all 6 of my blues. But remember, when we're doing the Cheerios, we're thinking about them as compounds. So we had these, they're together. And a better idea of this is when you do the FET for the compounds like we did yesterday. So if you have not done the FET for balancing chemical equations, that's what I recommend going and watching too. You can see when you add a compound, it puts the whole molecule up there. All right, so we've got 6 blues and 6 blues over here. We've got 2 oranges over here and 1 orange over here. So I'm going to have to make this a 2. So it will add another orange, but it will also add another green. Now I have 2 oranges, 2 greens, and 6 blues on both sides, and they're balanced. Okay? If you were doing the math portion of this, you would have your reactants and your products. You'd have K, Cl, and O. You would have 1K, 1K, 1Cl, 1Cl, 3 O's, and 2 O's. You're going to have to put a 2 in order. These are balanced and these are balanced, but these are not. So that's going to have to become a 6. That's why you add the 3 there. That's going to become a 6. That's why you add the 2 there, but it also changes your K's to 2 and your Cl's to 2. So you're going to have to put a 2 over here to make these 2. All right, going on to the back. Alrighty, so on the first one, we've got Na, so I'm going to put that as blue. We've got Cl, I'm going to put that as green. And we've got F2, which I'm going to put as orange. We're going to go through and identify our subscripts. So I've only got 1 Na, 1 Cl, and then 2 Fs. I have 1 Na, 1 F, and 2 Cls. So I'm going to go through and put my Cheerios. So I had 1 blue and 1 green and 2 oranges. Then over here I had 1 blue, which was the Na, and 1 orange, which is the F. And then I have 2 greens, which are the Cls. Okay, so my blues are balanced, but my greens are not balanced. So in order for me to do that, I'm going to have to put a 2 here because I need 2 greens. So now I have 2 greens, but it also changed my blue. So now I have 2 blues, 2 greens, and then I have 1 blue over here. So I'm going to add another blue because I need 2 of these NAs. But it also changed my oranges to blue, to 2. So now I have 2 blues on both sides, 2 greens on both sides, and 2 oranges on both sides. All right, on the number 4, that one's super easy. I'll just show you the answer for it in a little while. Let's move on down to number 5. So I'm going to identify PB as orange. I'm going to identify O as blue. H is green. And then I'm going to identify, I've got my other H over here as green and my Cl as yellow. So that's why you need all 5 colors, because sometimes you're going to have more than just the 3 elements. And I'm going to go through and identify my subscripts. So my first subscript is PB, and I only have 1 of those. Now remember, this 2 has to be distributed into everything into the parentheses. So I'm not changing my subscript. I'm just going to go ahead and distribute those to make it make more sense. So my O's, I have 2 of those, and I have 2 hydrogens, and I'm just going to mark out that subscript. Now I did not get rid of it. I just went ahead and distributed it. And I marked it out, but I did not get rid of it. I just showed it in different places. All right, so we've got one, and then I've got one hydrogen, one chlorine, two hydrogens, one oxygen, one PB, and two chlorine. So I've got my one orange, I've got my two blues, I've got my two greens for my hydrogens, I've got my one green here, and then I have my one yellow here. Over here, I have two of the oxygens, which I've said are green, right here. And I have two of the hydrogens, and then I have one of the oxygens, which is blue. I have one of the PB, which is orange, and two of the yellow chlorines. All right. So my oranges are balanced on both sides. My blues are not. So in order for me to do that, I need two blues over here. So I'm going to have to put a 2 in front. It changes my greens. Now I have to have two more greens, because remember 2 times 2 is 4. And we have two of the oxygens, so two blues. So now I have one orange on both sides, two blues on both sides, but then I have 3 greens on this side and 4 greens on this side, and I have one yellow here and 2 yellows here. So I could balance my greens, but I have a 1 over here with my chlorine and a 2 over here with my chlorine. Try to always stay the easiest first. If you ever see a 1 on either your reactant or your product side, balance that first. Don't try to balance the hard stuff first. Balance the easy stuff first. So we've got our chlorine, which is 1 here, and our 2 here. So let's put a 2 in front of this to make this 1 the same as this 2, which gives me another yellow chlorine, and it also gives me another green hydrogen. So now I have one orange on this side, and I have one orange on my reactant side. I have 2 blues on my product side and 2 blues on my reactant side. Then I have 1, 2, 3, 4 hydrogen, which are greens on my reactant side, and 1, 2, 3, 4 hydrogens on my product side, then 2 yellows and 2 yellows, and it's all balanced. Okay, so for that one, everything is balanced. So here are the answers for this worksheet. You'll need to pause it and make sure that your paper is correct. So we did 1, 2, 3 together. Here is 4, where you'll have 2 blue hydrogens. You start out with 2 blue, but you're going to have to add a coefficient of 2 to have 4. And then you have your 2 red oxygens. On this side, you'll have your 4 blue hydrogens and your 2 red oxygens. We did 5 together. Here is 6. This one is pretty difficult. I'm not going to expect an 8th grade science student to know how to do this one. You can try it, but it's definitely a more advanced problem. So I'm definitely not going to put this one on your test. Here is numbers 7, 8, and 9. So you can check those. There is 10, 11, and 12. And then you've got 13 and 14. So that's all I'm going to do on this part right here. I will do numbers 15 through 20 in a separate video.